why do we care about all this stuff? Well, in the 1950s, when it became clear that cholesterol was playing a role in cardiovascular disease, the first observation was people with very, very, very high total cholesterol, because at the time that was all that could be measured, was total cholesterol. By the way, what that meant was the total amount of cholesterol in all of your lipoproteins, in your HDLs, in your LDLs, and in your VLDLs. Those three lipoproteins constitute the amount of total cholesterol you have in the lipoproteins. We can come back to this idea because it's important. That represents about 10% of the total cholesterol in your body. The total cholesterol concentration was loosely correlated with cardiovascular outcomes, but only at extremes. Meaning, if you took people whose total cholesterol was in the top 5% and compared them to people whose total cholesterol was in the bottom 5%, there was a clear association with cardiovascular disease. March forward many, many decades, we came to realize that actually this low-density lipoprotein, which is a subset of your total cholesterol, but it's the cholesterol contained within the low-density lipoproteins, that's much more strongly associated. And what we now know is the case is there's an even better way to predict risk than just saying how much cholesterol is contained within the low-density lipoproteins. A better way to predict risk is to add up the concentration of all the ApoB particles. So that number, ApoB, measured in milligrams per deciliter, is the concentration of the entire burden of particles that are capable of undergoing something that I'm sure we'll talk about, which is the initiation and progression of atherosclerosis.
So how the ApoB number, can you talk about how that, so you mentioned LDL, total LDL cholesterol. That number is like it's like determined by some equation, right? And
well, it can be, but it can also be measured directly. Yeah, so there's...
Would that be particle number though, if it's called, no?
No, and, so there's two ways to go about doing this. So in the olden days, and unfortunately many labs still do this, they rely on an equation called the Friedewald equation. So total cholesterol is relatively easy to measure. So you draw the plasma, you spin it down, and you basically lyse all of the lipoproteins, and you can measure total cholesterol. So if you just basically apply something to lyse all of the proteins, you'll say, all of the lipoproteins, you'll say total cholesterol is 200 milligrams per deciliter. Then they directly also measure two other things. They can directly measure total triglyceride concentration, and using a separate assay, they can measure the total concentration of cholesterol within the HDL particles. So now you've measured total cholesterol, HDL cholesterol, and triglyceride. The Friedewald equation stems from an observation that kind of, sort of, on average, sometimes, VLDL cholesterol is approximately 1/5 the triglyceride concentration. So the Friedewald equation is quite literally used to estimate LDL as follows. LDL cholesterol is estimated as total cholesterol less HDL cholesterol less triglyceride concentration divided by 5, if you're doing everything in milligrams per deciliter. And unfortunately, most labs still do that. So when you look at your cholesterol report, it'll say LDL-C, it'll give a number, and unless it says direct, you can assume they've done the Friedewald equation, which is, I've seen that wrong more often than I'm seeing it right. A good lab will do a direct assay. They will actually measure LDL concentration, and they will give you, in milligrams per deciliter, the total concentration of LDL-C. That is still an inferior predictor of risk relative to ApoB.
Yes. Okay. So the reason I wanted to mention that LDL-C is because, as you mentioned, many labs do measure it indirectly. And there are many types of LDL, right? So there are different densities and sizes. So I'm curious about what your thoughts are on the different sizes of, like, more atherogenic sizes of LDL, such as the smaller dense particles. And, like how you view that, like the different particle sizes and the particle number, and then of course ApoB. So like the whole.
I mean, there's been